Welcome once again to the class, and we are going to have a look at the next question, which is as follows: that we have to derive the relativistic length contraction, and in order to derive that relativistic length contraction, we have to use actually Lorentz transformation. Okay, so using Lorentz transformation, we have to derive the relativistic length contraction. So that is the question which was asked in UPSC 2013 paper 1 physics optional in the form of question 2 subpart D. Okay, so let us look at this particular question. Okay, so first of all, I am just right now I am just drawing this particular diagram. So all of you must draw this diagram in your notebook along with me. This is suppose your S frame. This is Y axis, this is Z axis. Okay, and this is what? This is your X axis of this S frame. Okay, then we have another frame which is S prime. We have one more frame which is S prime. So this S prime frame, let me draw it properly. Just a second. Let me draw it properly. Yes. So this is what? This is Y prime. Okay, and this is what? This is Z prime. Okay, this is Z prime, and this is what? This is O prime. Okay, origin of S prime frame. This is S prime frame, right? So O prime is the origin of S prime frame, and O is the origin of S frame. O is the origin of S frame. Now this particular axis. Now this S prime frame has this axis which is coinciding with this. So this will be called as X prime. Okay, so this X prime is the axis of S prime frame, and X is the axis of S frame. Okay, so this is the situation which we have with us right now, and let us assume that this particular frame is moving with a velocity v in the rightward direction. Okay, velocity v in the rightward direction. We have one more thing along with that. We have one cube over here. We have one cube which is placed over here, and that cube is something like this. Okay, that cube looks something like this. Let me draw the cube properly. So I am drawing the cube. So let us see. I am drawing the cube properly. You guys must also draw all this stuff in your notebook along with me. Okay, only then you will understand each and every concept very clearly. Otherwise it will be quite difficult for you to understand. Okay, so draw along with me in your notebook. So PYQ solutions are going on right now. You must be knowing this. So let us suppose this is point number A, and this is suppose point B. This is suppose point C. Those are the vertices of the cube. Those are what? Those are vertices of the cube. So A point, B point, C point, D point. Okay, and what else do we have? E point. Okay, F point, G point. Okay, so, and this particular point I am not naming. One more point is there which is left. This particular point which I am not naming because there is no need to name that particular point. So I am leaving that particular point. Okay, so this is suppose the situation. So what the situation is actually, I am telling you right now. So we have one S frame. This S frame is stationary frame. Okay, this S frame is what? It is stationary frame. So this S frame has three axes. Okay, this S frame has three axes. One axis is X axis, another axis is Y axis, and third axis is Z axis. Okay, so X, Y, Z, three axes are there, and S frame has these three axes, X, Y, and Z. Then S prime frame. Okay, S prime frame again has three axes. X prime. Okay, S prime frame again has three axes, which is X prime, Z prime, and Y prime. So these are the three axes of the S prime frame. This S prime frame is not a stationary frame. This S prime frame is moving with the velocity v in the rightward direction. Okay, so this S prime frame is moving with the velocity v in the rightward direction, and one cube has been placed. This green colored cube has been placed in this S prime frame. Okay, so this green colored cube is placed in this S prime frame, and in this green colored cube, these are the vertices of this green colored cube. A, B, C, D, E, F, G, etc. All these are vertices of this green colored cube. This S prime frame is moving with velocity v in the rightward direction, and along with this S prime frame, this cube is also moving. Okay, for example, when you sit in a bus, what happens? When you sit inside a bus, you are moving along with the bus. Okay, when you sit inside a bus, what happens? Whenever you sit inside a bus, you are moving along with the bus, right? Similarly, this S prime frame is moving with velocity v in the rightward direction. So this cube has been placed in this S prime frame. This cube, this green colored cube has been placed in this S prime frame. Okay, so this cube is placed in this S prime frame. So S prime frame is moving rightward with velocity v, and this green colored cube is placed in this S prime frame. Okay, and it is also moving in the rightward direction with velocity v. Okay, so this is the situation which we have with us. Okay, hopefully you got the situation. O is the origin of S frame, O prime is the origin of S prime frame. So these are the things which we have with us. Then we have some more things which we need to consider. There are some more things which we need to consider over here. So the first thing which we have to consider is that, let me draw it properly. The first thing which we have to consider is the distance from here till here. Okay, let me mark it with blue color. So this particular distance, what is it? This particular distance is actually x1 prime. This particular distance is what? X1 prime. And another distance is what? From here till this point B, there is another distance. And this particular distance is what? This particular distance is x2 prime, right? This particular distance is x2 prime. So this is the thing. This is the thing. And we have two more things with us. Let me mark it with red colored pen. Okay. So will this x1 prime and x2 prime, now first of all answer this question, will this x1 prime and x2 prime, will these two quantities ever change? Let me ask you one question. This x1 prime, which is the distance from O prime, okay, so distance from O prime to A point and distance from O prime to B point, will these distances x1 prime and x2 prime, will they ever change? So the answer is no. The answer is no. x1 prime and x2 prime will never change. Why will they never change? Why will they never change? Because this S prime frame is moving in the rightward direction with v velocity, and this green colored cube is also moving in the rightward direction with v velocity only. Okay, so the velocity of this frame and this cube both are same. So actually this particular cube is moving with this frame, along with this frame. Just consider you are sitting in a bus. So when you are sitting in a bus, you are moving along with the bus. Similarly, you have the same velocity as bus. When you are sitting inside a bus or inside a car, what happens? You have the same velocity as the car or the same velocity as the bus. Okay, so this is the thing. So S prime frame is moving in the rightward direction with velocity v, and this cube is also moving in the rightward direction with velocity v only. So both of them have the same velocity. So we can say that with respect to this S prime frame, this particular cube is stationary. Did you get the point? With respect to this S prime frame, this particular green colored cube is stationary with respect to this S prime frame. Okay, so this is the thing which we have with us. Now what are the other things which we have with us? Let me draw it properly. The other things which we have with us over here are as follows, that from this point up to this particular point, okay, from this point up to this particular point, what is the thing? Now let me mark this particular distance. Okay, so what is this? From O point, this point A, what is the thing? It is x1. It is x1. Okay, and what is this point B? What about this particular point B? With this particular point B, let me draw it properly. I don't know where to draw it, so let us draw it with some other yellow colored pen. Okay, so that it appears clearly. So from here up to here, and that is the distance of point B. Okay, distance of point B. So let me mark it. What is this? This is suppose x2. This is what? This is x2. Now from this point O, the distance of this point A is x1. From this point O, the distance of this point B is x2. From this point O prime, the distance of this point A is x1 prime. From this point O prime, the distance of this point B is x2 prime. Okay, got it? So these are the things which we have with us. Okay, now what is the other thing? So let us see what happens next. Let us see in this particular thing. Now this particular velocity v is not a small velocity. Okay, let me tell you that this particular velocity v is not a small velocity. Okay, if the velocity v is very small as compared to speed of light, what will happen? If velocity v is very small as compared to speed of light, then what will happen? Then in that case, relativistic mechanics will not hold. Okay, relativistic mechanics will hold, but it will have negligible impact. Okay, if this velocity v, let me tell you, if this velocity v is very small, then what will happen? The relativistic variation will be very small. It can be neglected. Classical mechanics will be sufficient to solve the question. Okay, if this velocity v is small, then classical mechanics will be sufficient to solve this question. Okay, but this velocity v is comparable to the speed of light, suppose. Okay, comparable to the speed of light means 1/10 of the speed of light. Okay, or 1/15 of the speed of light, 1/12 of the speed of light. Such things, such high velocities this particular S prime frame is having. Okay, very high velocity. And this cube, which is stationary with respect to this S prime frame, it is also having such a high velocity. Okay, because it is moving along with this S prime frame, so it will also have that much high velocity comparable to the. So this green colored cube will also have high velocity which is comparable to the speed of light. Okay, so these are the things which we have with us right now. So let us start the answer to this particular question. Let us start the answer to this particular question. So let me write the points which we need to consider over here. So what are the points which we need to consider? So let us see. Length. Okay, length is contracted in the direction of motion. Okay, length is contracted in the direction of motion. So length is contracted in the direction of motion. What does it mean? And so all these stuff are, everything is moving along the x-axis. Okay, this S prime and this cube, this S prime and this cube, both are moving along the x direction. This S frame is stationary. Okay, so it is one dimensional motion. Clearly it is one dimensional motion. All the motion is taking place along the I cap direction. Okay, we can also call this particular direction as what? We can call it I cap direction. Okay, along the x-axis direction. So length is contracted in the direction of motion. What does it mean? So this particular length AB, it will be contracted. This cube is moving along this direction, I cap direction. So in the AB will be contracted in this direction. Okay, so AB will be contracted because AB lies in I cap direction. The AB edge. Okay, the AB edge of the cube. What happens to that? The AB edge of the cube will contract because it is along the direction of motion. AB edge is along the direction of motion, so it will contract. Okay, similarly DC edge is along the direction of motion, so it will contract. Similarly this particular edge is also along the direction of motion, so it will also contract. Similarly this particular edge, this particular E and this edge, okay, it will also contract because it is in the direction of motion. So this is the thing. So length is contracted in the direction of motion, but no contraction in the direction perpendicular to the direction of motion. Okay, so let me write it properly. But no contraction in a direction perpendicular to the direction of motion. Okay, to the direction of motion. So what is the thing? Length is contracted in this direction, and this AE axis, this DF axis, this CG axis, let me mark it with this. So let us suppose this is point H. So what will happen? AB will contract, DC will contract because it is in the direction of motion. So AB will contract, DC will contract, FG will contract, EH will contract. But what will happen to the other edges? AE will not contract because it is perpendicular to the direction of motion. AE will not contract. AE will not contract because it is perpendicular to direction of motion. BH will not contract because it is perpendicular to direction of motion. CG will not contract because it is perpendicular to direction of motion. DF will not contract because it is perpendicular to direction of motion. So these are the things. Then what do we have next? AD will not contract. AD will not contract because it is perpendicular to direction of motion. BC will not contract because it is perpendicular to direction of motion. HG will not contract because it is perpendicular to direction of motion. EF will not contract because it is perpendicular to direction of motion. Okay, but AB will contract because it is parallel to direction of motion. DC will contract because it is parallel to direction of motion. FG will contract because it is parallel to direction of motion. EH will contract because it is parallel to direction of motion. So these are the things which we have with us. So length is contracted in the direction of motion, but no contraction in a direction perpendicular to the direction of motion. So these are the things. So let me have some water, friends. Let me have some water because I am feeling really thirsty now. Yes, welcome once again. That particular question which we were looking. So length is contracted in the direction of motion, but there is no contraction in the direction perpendicular to the direction of motion. This is the thing which we have learned till now. Okay, so let us see. Now LOX, what does it mean by LOX? So let us see. What will be the proper length in x direction? So with respect to this S prime frame, this particular cube, this is stationary. So proper length in x direction will be with respect to this S prime frame, because this cube as it is stationary with respect to this S prime frame. So naturally the original length, that is the unaltered length, original length will be observed with respect to this S prime frame. Original length of AB, original length of EH, original length of FG, original length of DC will be observed with respect to S prime frame, because this particular object is stationary with respect to S prime frame. So what is the proper length? Proper length will be x2 prime minus x1 prime. x2 prime minus x1 prime will be the proper length of AB, or you can say of DC or EH or FG, whatever. Okay, so the proper length will be x2 prime minus x1 prime. So let us see. So x2 prime minus x1 prime is equal to proper length in x direction, and let us denote it by small LOX. Okay, LOX. So that is the proper length in x direction. What is it? That is the proper length in x direction. Okay, so this is the thing which we have seen. Now capital LX is equal to x2 minus x1. That let us assume that is what? That is observed length. Let us assume. So capital LX. So x2 minus x1, from here till here it is x2. Okay, and from here till here it is x1. So if we want to, the observed length will be observed with respect to stationary frame. Okay, because with respect to this stationary frame, this object is moving. So the contracted length will be visible in this particular frame. Okay, contracted length will be visible in this S frame. So the contracted length will be x2 minus x1. Okay, x2 minus x1 will be the contracted length, because the distance from O to B is x2 and distance from O to A is x1. So observed length will be x2 minus x1. So capital LX is equal to x2 minus x1 is equal to what? It is observed length. It is observed length. Now by Lorentz transformation, which I am going to teach you in the special relativity, I haven't taught it yet, but I will teach it very soon. I will teach the Lorentz transformation very soon. I haven't taught it yet, but soon I am going to teach it. So by Lorentz transformation, what do we have? x2 prime minus x1 prime is equal to, now x2 prime is given by gamma x2 minus vt. This is from Lorentz transformation, which we will learn in the lectures. When I will teach this special relativity, we are going to learn it. But if you have learned in the Delhi offline, or if you have learned at some online learning platform, or you can find the YouTube lectures as well. So x2 prime is equal to gamma x2 minus vt, and x1 prime is equal to gamma x1 minus vt. So these are the things which we have with us. Now when we subtract this from this, what do we get? Gamma x2 minus x1 is the thing which we get. Okay, so proper length in x direction is equal to what? This x2 prime minus x1 prime is what? Proper length in x direction, and x2 minus x1 is what? Observed length in x direction. Okay, now proper length is equal to gamma times observed length. Proper length is equal to gamma times observed length. Okay, so this is the thing. So you can clearly see LOX is equal to gamma LX. You can just substitute LOX in the place of this thing, and in place of x2 minus x1 you can substitute LX. So over here you will substitute LX, over here you will substitute LOX, and you will get this particular entity. LOX is equal to gamma LX. Now LX is equal to LOX by gamma. Okay, from here this will go in the division, so it will become LOX by gamma. Now LOX is as it is. LOX is as it is. Now what about gamma? Gamma will become, so you already know that gamma is equal to what? Gamma is equal to something of this kind. Gamma is equal to something of this kind. Okay, so this is the conversion factor actually. So 1 upon gamma will be equal to square root of 1 minus v square by c square. So 1 upon gamma will be equal to this entity. So LX is equal to LOX multiplied by square root of 1 minus v square by c square. This is the thing which we have with us. Now what does it mean by LX is smaller than LOX? So you can have a look over here. Okay, so LOX is what? LOX, you can have a look. LOX is proper length. Okay, so LOX is what? Proper length. LOX is proper length. So observed length is less than proper length. LX is what? It is observed length. So observed length is less than proper length. Observed length is less than proper length. So this is what? This is Lorentz-Fitzgerald Lorentz Fitzgerald length contraction. This is Lorentz Fitzgerald length contraction. Okay. So the length has been contracted. Length has been contracted. That is, observed length is less than proper length. Length has been contracted. Okay. So Lorentz Fitzgerald length contraction. Now, similarly, now in y and z direction there will be no contraction. Okay. I have already told you that length is contracted in the direction of motion, but no contraction in a direction perpendicular to direction of motion. So the motion is taking place in x direction. Motion is taking place in x direction. So no contraction in y and z direction. No contraction in y and z direction. So observed length and proper length both are going to be the same in y and z direction. So y2 prime minus y2 prime minus y1 prime is equal to y2 minus y1 is equal to LOI is equal to capital Ly. Then similarly, because no contraction, why is this so? Because motion is in x direction. Okay, this is because above two equations arise because no contraction in above two equations arise because no contraction in y and z direction. No contraction in y and z direction, as motion is purely in x direction. So the motion is purely in x direction. So y and z are perpendicular directions. So observed length will be equal to contracted, means altered length will be, there will be no alteration in length. I mean, okay. Proper length is equal to observed length. Okay. What does it mean? Proper length is equal to observed length. Okay. In y direction. Similarly, in z direction also proper length is equal to observed length. Okay. Because the motion is purely in x direction and y and z are perpendicular directions. So no contraction in perpendicular directions. Okay. So this is the thing. So this is how the question has been solved already. Okay. When you derive this particular equation you have derived, and this particular equation you have derived, this particular equation you have derived. So it is what? It is Lorentz Fitzgerald length contraction. So you have successfully derived. Okay. So the question, derive the relativistic length contraction using Lorentz transformation. So the question has been solved successfully. So you have successfully derived the relativistic length contraction using, where did you use the Lorentz transformation? You have used the Lorentz transformation over here. x2 prime is equal to gamma times x2 minus vt, and x1 prime is gamma times x1 minus vt. These are what? Lorentz transformations. So using Lorentz transformation, you have successfully derived relativistic length contraction. Okay. So in this way, you have successfully solved this particular question number 2D of UPSC Physics optional paper 1 2013. Now this question 2D. Now in the next class we will solve question 2E. Okay. So thank you very much. One playlist will appear over here. Okay. In the form of end screen of this video, one playlist is going to appear over here. You can click on that playlist and you can have a look at all the previous questions which I have already solved. So thank you very much.